All right, welcome to the series on algebra. And so for this first video, we're going to take a look at what algebra is, just kind of outline some of the rules and underlying concepts of algebra, and then begin to start looking at expressions and equations and simplifying and solving those expressions and equations. So first of all, algebra. What is it? How would we define algebra? And I thought about this question a lot before doing this video, and here's what I came up with. So this is just my definition. But algebra is the system of rules and the manipulation of numbers. So we could think values of numbers and symbols. And I'm thinking values as well as numbers to just make it a little more broad. So it's the rules and the manipulation of values and symbols. And one of the core foundations of algebra, and especially when it concerns the manipulation of those numbers and symbols, is understanding rules of equality. And the best way, in my mind at least, to understand those rules is balance. In algebra, when we're manipulating, it's all about balance. So we want to think about keeping everything as balanced as possible, not even as balanced as possible. Further than that, we want to make sure that everything stays balanced. And when we talk about equality and moving things around, we want to maintain whatever balance it is that we're starting with. So here's a couple of equations that I just kind of wrote out. We know their equations because we have that equal sign. So what does that equal sign mean? The equal sign means it just means that the values that are on both sides are in a balance. 7 times 2, if I were to simplify that, I would get 14. And then 140 divided by 10, if I were to simplify that, I would also get 14. And this makes a little bit more sense. We have that balance. They may look different, but they are balanced. So we were thinking about weights and a physical balance here. They would weigh the same and they would balance out. 3 plus 8 equals 11. Well, if I were to simplify 3 plus 8, I would get 11. And of course, 11, again, does equal 11. And then this last one, 14 plus 130 gives me 144. Dividing that by 12 gives me 12. And of course, 12 does equal 12. So again, it's all about balance. It may not look the same on each side, but with a little bit of, again, manipulation, as long as we are maintaining balance, we can kind of see and reveal some additional information. All right, so along those lines, we can manipulate equations and move things around as long as we have and as long as we maintain balance. So I could just simplify this. 3 plus 6 equals 9. Well, yeah, we know 9 equals 9. But we can do some other things with this as well, as long as we maintain balance. So I'm actually going to change the left side here a little bit. Instead of doing 3 plus 6, I'm going to subtract 6 and rewrite this as 3 plus 6 minus 6 equals, well, if we go back to that image of the balance, what I've done is taken some out of this side, right? I had, a 6, let's say, on this side, and I took it out. Now I have two options to maintain or regain balance. I can either put the 6 back in, or I could come to the other side and take 6 out of that as well. And so that's what I'm going to do. Instead of adding the 6 back to maintain balance, I'm just going to subtract 6 from the other side. And now we will simplify. So 3 plus 6 minus 6. Well, 6 minus 6 is 0. 3 plus 0 is just 3. And then 9 minus 6 is also 3. And so you see, we still have balance because maybe you've heard this before. What we did to one side, we did to the other. Now, in this example, that was kind of a silly process to highlight this property. of algebra and how we can manipulate and still maintain balance. So not much practical use here, but hopefully you understand this idea is that we can manipulate expressions and equations. We can do that as long as we are maintaining balance. And that simple way of putting that, again, and what you've probably heard before, if we do to one side, we do to the other. And I guess I could have just said that, but I didn't want to just come out and say that or give you that rule without kind of visually showing you and helping you understand the concept behind that rule. Now, before we dive in and look at a few more of these rules and properties, I do want to briefly talk about variables as well, because we are going to use some variables in helping to understand this. And so variables come into play in sort of two main ways. Variables can either represent something that could vary. So based on the context, we're using a variable because in one instance it might be this value, and another instance it might be a totally different value. So we use a variable because it could vary. That's part of the reason that it's called a variable. Another situation or some context where variables come into play is if there is a value that's unknown. Maybe it does represent a singular value, but at the time, at that particular moment that we're talking about it, it's a value that is unknown. And so we can use a variable to represent that. So I have a couple situations of context that are very similar, but slight tweaks to the context. One will be a value that is going to vary, and one will be a value that is a singular value. It's just unknown based on the context and where we are at the time in that given context. So Steph makes an hourly wage of $12.50. Steph already has $372 in his bank account. So if I wanted to represent this with either an expression or an equation, let's go in and kind of look at what we have and how we could represent the amount of money that Steph has. So an hourly wage of $12.50. Well, I don't know how many hours he's working, right? But it's more than just an unknown, because not only do I not know how many hours he's working, based on this context, I don't have a way to figure that out, and it's not telling me to figure it out. So this, in 1 week could be one value, and another week could be another value, and another month could be another value. So in this context, this amount of hours is something it's going to vary. So we're going to use a variable to represent that. And how would we figure out if we knew how many hours he worked, how much money he makes? Well, we would take that hourly wage, the $12.50, and we would multiply it by some value. So we could say, we could use H to represent hours, or kind of a stereotypical variable is to use X. Doesn't really matter what that variable is. When you're working, if you write it one way, but an opportunity or context shows it a different way, that's okay. We can just replace those letters or those symbols one to one. It doesn't matter. Another way we could write that is without the multiplication symbol, just do 1250x. And then he's already got $372, so let's add that 372 as well. And so in this situation, we have our variable here, and it's representing something that could vary. This could be very useful in showing, maybe at the beginning of the week, we don't know how many hours he's going to work, but we do know that this kind of expression we could use later, no matter what the hours are, whatever that varying value is that we could plug in here, this one expression is going to help us find that. So let's look at some similar context. So we've got Steph here again, makes an hourly wage of $12.50, and he had $372 in his bank account on Monday. When he deposited his check Friday, he had a new balance of $822. So this context is different because we actually have a specific amount of money at the end of the context, which means we are going to have a specific hourly wage happening. This is not a situation where this is going to vary, but it is still unknown. And so I still could use, and I'm going to use, a variable to represent that amount. So again, we have the 1250. I guess I don't need the dollar sign just to write the expression. X plus 372 here, but this time we know it all has to equal $822. And so the variable in this case isn't representing sets of values that could vary, where we could plug in different things. In this case, the variable is representing one specific value, but that value is unknown. At this point, we don't know what that value is, so we can represent that with a variable. And we could solve this to figure that out, but we're going to get to solving equations a little bit later in this.